So this is question 13. It's a series. Okay, so what we're going to be doing is we're going to be proving this to be true. Now this is the general formula Tn. Tn is basically r squared plus 1 multiplied by r factorial. Okay, and what we're going to do is we're going to test number 1. Part 1 is testing p of 1. Test p of 1. Now, p of 1, the left hand side will be t1, and t1 is going to be 1 squared plus 1 times 1 factorial, which is going to be 2 times 1 factorial, which equals 2. So t1. RHS, this is a sum for Sn or S1. So we have to find out what S1 is. And S1 is going to equal 1 into 1 plus 1 factorial plus 1 into 2 factorial equals 2. Okay, once you've done that, what we're going to do is we're going to try and prove this for assume true for p of k. So part 2, assume true for p of k. Now, when you assume true for p of k, what we're going to do is we're going to replace k. So it's going to be k, r equals 1, and this is going to be r squared plus 1. R factorial. That's going to equal n into n plus 1 factorial. Or sorry, and that's, we're going to replace n with k, so it's actually going to be k here. Now, next thing we're going to do is part 3, and we're going to assume for k plus 1. Now remember, when it's the sum to k, it's assumed that's t1 plus dot 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 all the way to tk. When it's k plus 1, it's going to be t1 plus dot dot tk, and then there's going to be tk plus 1 at the end. Okay, that's equal to r squared plus 1 by r factorial. This is r equals 1, and then this is going to be s of k plus 1, which is going to be k plus 1 multiplied by, replace that k with k plus 1, and we're going to get k plus 2 factorial. Now, we have then is, we then know that this here, t1 all the way to tk, is going to be equal to k times k plus 1 factorial. Okay, now we have to find out what t of k plus 1 is. Remember that tn is this, so we're going to find out what tk plus 1 is going to be k plus 1 squared plus 1 times k plus 1 factorial, basically replacing r with k. And we're going to get k squared plus 2k plus 1 plus another 1 to k plus 1 factorial. And then we're going to end up with k squared plus 2k plus 2 times k plus 1 factorial. So, it's going to be plus k squared plus 2k plus 2 k plus 1 factorial. And this is t of k plus 1 here. This here represents s of k. Okay, then we're going to have k plus 1. Now see the way everything is in terms of k plus 1 factorial. I'm going to change this here. K plus 2 factorial is going to get changed to k plus 1 by k plus 2 times k plus 1 factorial. Now, what happens is we look at both sides and we factorize. So we end up getting k plus 1 factorial into k, this part here, plus k squared plus 2k plus 2. We're just taking the left hand side only. Then we're going to end up with k plus 1 factorial into k squared plus 3k plus 2. Now we're going to separate out this k plus 1 factorial. Then we're going to get a reference number of 2, which is 2 and 1. It's going to be k plus 2 times k plus 1. And now we can see that the left hand side equals the right hand side. So LHS equals RHS. Okay. So P of k plus 1 is true if P of k is true, and then therefore P of n is true via the principle of mathematical induction. Of mathematical induction. Okay.